The ocean floor is breathing. Scientists just recorded its pulse for the first time in the history. How did it all begin? Scientists found something impossible 7 miles underwater that changes everything we thought we knew about the ocean. Picture this. You're in the deepest, darkest place on Earth. No sunlight, no warmth, crushing pressure that would flatten you instantly. This is the abyss, and it's supposed to be dead. But here's the twist. Deep beneath the Pacific, pressure sensors started detecting something extraordinary. A rhythmic pulse, occurring every 3 to 5 hours, like the ocean floor itself was breathing. Wait, let me say that again. The ocean floor is breathing. For decades, we've treated the seafloor like a graveyard, static, lifeless, just sitting there collecting sediment. But this discovery shatters that completely. The abyssal plains, those vast underwater deserts we thought were geologically dormant, are actually alive with a pulse that's been beating for potentially millions of years. These aren't earthquakes. They're not volcanic tremors. The pressure changes are too regular, too synchronized across thousands of square kilometers. Marine geophysicists are calling it abyssal respiration, and it's powering massive nutrient upwellings that support entire deep-sea ecosystems we never knew existed. The ocean isn't dead. It's alive, and it's breathing beneath us. If the ocean floor has been breathing this entire time, driving circulation patterns we've completely missed, then everything, our climate models, our understanding of marine life, even our search for life on other planets, might be completely wrong. Today, we're diving into one of the most mind-blowing discoveries in oceanographic history. The story begins 7 miles underwater, in a place darker than space. Scientists dropped pressure sensors to hunt earthquakes. Instead, they found something that shouldn't exist. Every 3.2 to 4.8 hours, pressure readings across vast seafloor areas rise and fall like a giant, slow heartbeat. Water columns rising and falling by several centimeters across areas larger than entire states. At first, scientists thought their equipment was broken. Think about it. Temperatures just above freezing. Pressure 600 times greater than at sea level. Complete darkness. Equipment fails down there constantly. But then something incredible happened. Multiple sensor arrays, thousands of kilometers apart, started recording identical patterns. Same mysterious pulse. Same timing. Same rhythm. This wasn't equipment failure. This was real. The pressure waves weren't coming from the surface. Storms create pressure variations, but they dissipate rapidly with depth. Tides operate on 12 and 24-hour cycles, completely different from these mysterious pulses. When they looked at current meters and temperature sensors, they found correlations no one expected. Every time abyssal pressure peaked, cold, nutrient-rich water began rising from sediment layers. When pressure dropped, warmer water descended. It was like watching the ocean floor literally breathe, inhaling and exhaling water masses in a rhythm invisible to science until now. The strongest signals appeared along mid-ocean ridges and areas with thick sediment layers. Whatever was causing this breathing, the seafloor's geology was crucial. But that's only half the story. Dr. Maria Santos knew she was onto something revolutionary, proving it would require the most advanced deep-sea monitoring system ever built. Santos deployed pressure sensors, seismometers, and chemical analyzers working together like a massive underwater detective system. Their mission: decode the mystery of the breathing seafloor. But when scientists dug deeper, they found something in the mud that changed everything. Those boring sediment core samples from the abyssal plains? They contained chemical layers that told an incredible story, evidence of periodic water infiltration and expulsion stretching back millions of years. The seafloor wasn't solid rock. It was more like a giant, water-filled sponge. The leading theory involves thermobaric convection. Heat from Earth's core warms water trapped in seafloor sediments. As this water expands and becomes less dense, it creates pressure that forces water upward through tiny pore spaces. This creates the exhale phase, pushing nutrient-rich water into the deep ocean. Then, as the system cools and pressure equalizes, water gets sucked back down the inhale phase. Computer models based on sediment structure and geothermal heat accurately predicted the 3 to 5 hour cycle times. The process requires perfect conditions: sediment layers thick enough to store massive water volumes, sufficient geothermal heat to drive convection, and seafloor topography that allows coordinated breathing across vast areas. And then they made a discovery that nobody saw coming. This breathing pattern is generating previously unknown circulation cells deep beneath the ocean. Tracer studies using inert gases show water masses being transported vertically through hundreds of meters of sediment, then traveling laterally across entire ocean basins before diving back into the seafloor thousands of kilometers away. It's essentially a massive, slow-motion conveyor belt operating beneath the ocean we thought we understood. If what scientists found is true, it doesn't just change ocean science. It changes Earth itself. The ocean floor isn't just breathing. It's feeding an entire hidden ecosystem that spans the globe. Remember those nutrient upwellings? They're supporting life in ways that will blow your mind. Scientists traced chemical signatures from deep sediment nutrients all the way to the ocean surface. The seafloor's breathing is literally feeding marine life from the abyss to the waves above. But what if everything we thought we knew about our planet's climate was wrong? Our climate models treat deep ocean circulation like it's driven mainly by surface processes: wind, temperature differences, evaporation. What if we've been missing a massive piece of the puzzle? The deep ocean stores vast amounts of atmospheric carbon. If seafloor breathing is transporting carbon-rich waters through pathways we never knew existed, our predictions about climate change could be dramatically wrong. Marine conservation efforts typically focus on surface and midwater ecosystems. But if seafloor breathing creates interconnected habitat networks across ocean basins, we might be protecting the wrong areas entirely. Imagine trying to save a forest while ignoring the root system connecting all the trees. The rhythmic breathing pattern suggests Earth's oceans are far more geologically active than we ever imagined. Dynamic interactions between geological processes and oceanic circulation operating on timescales from hours to millions of years. Astrobiologists studying Europa and Enceladus, those icy moons with suspected subsurface oceans, are now completely rethinking their search for alien life. If Earth's seafloor can support complex circulation through sediment breathing, similar processes on other worlds could create habitable environments in places we never considered. The implications stretch far beyond our planet. We might be looking at a fundamental mechanism of how water worlds work. Not just Earth, but potentially dozens of ocean worlds throughout our solar system and beyond. The ocean floor's breathing might be the key to understanding life itself. So we've discovered our planet's ocean floors are breathing, driving circulation systems that support deep sea life and potentially control global climate patterns. But here's the thing that keeps scientists awake at night. This revelation opens more questions than answers. How long has this been happening? Geological evidence suggests similar processes operated throughout Earth's history, but we don't know if current patterns are stable, accelerating, or changing due to climate change. But scientists noticed something strange: irregular hiccup patterns in the breathing cycle. These aren't part of the regular rhythm. They're sudden pressure spikes that don't fit any known pattern. Some scientists think they indicate interaction with seismic activity. Others believe they're signs of changes in geothermal heat flow. Or they could be something entirely unknown operating at the boundary between geology and oceanography. The next phase involves expanding sensor networks to all ocean basins. Are we looking at a global phenomenon? Or is the Pacific special? But here's what really excites researchers. They're developing new techniques to trace water movement through sediment layers over longer time periods. We might be on the verge of discovering that every ocean on Earth and beyond is breathing. What ocean mysteries fascinate you most? Next week, we're investigating the strange sounds emanating from oceanic trenches that have marine acoustics experts completely baffled.